So if you read through the question here, you'll see that this is kind of backwards compared to what we're doing in the last section. In the last section, we were given a data value and asked to find a probability or a percentage. In this question, we're given a percentile, which remember is a percentage, and we're asked to find the data value, in this case, a test score. All right, so let's think about what we're being asked here, right? I know that I'm looking at the 90th percentile. The 90th percentile is the data value that has 90% of the data below it, to the left. All right, so let's see if we can kind of sketch that. I'm looking for a number probably pretty far to the right, right? It's going to be here somewhere. So that this area over here is 90% of the population. Remember, that is the same as 0.90. Okay, how am I going to do this? Well, look, I'm going to use that same z-score formula, right? Because once again, I know the mean, it's 514, and I know the standard deviation, it's 103.2. Okay, so what I'm going to do, I'm going to go to the table, all right? And here, you need to be clear about what we're doing. The numbers here in this outer column in the upper row, remember, those are the data values. The numbers here in the body of the table, those are the percentages or the probabilities. I was given a percentage, right? So what I'm going to do is I'm going to go to the percentage section of the table. That's the body here. And I'm looking for 0.90. Okay, 0.90 doesn't appear on the table, right? 0.9000 isn't on here. And that's often going to happen, and that's okay. When it does, there's a lot of different textbooks. They'll take different approaches. They'll do this interpolation business. I just take the value that's closest, right? I'm looking, I see I've got 0.8997 and 0.9015. 0.90 is between the two of those somewhere, right? I'm looking and I'm thinking this value here, 0.8997, is closer to 0.9 than 0.9015. So that's the value I'm going to use. This is the z-score. Oh, careful. What value am I going to use? What's the corresponding z-score here? Well, I'm going to use 1.2 and 0.08. So the z-score is 1.28. Well, that's nice, I guess, but I wasn't asked for a z-score, right? I was asked for a data value, for a test score, but we've got a formula. Remember the z-score formula. Z equals x minus mu divided by sigma. Well, I know mu and sigma, those are the mean and standard deviation. Was given them in the question. And I know the z-score. I just found it right here. So let's put those numbers in. 1.28 equals x minus 514 over 103.2. Now all I have to do is solve for x. Right? Solve for x and I'm home free. Multiply both sides by 103.2. Right? Multiply over here and over here. And we get x minus 514 equals 132.96. Then add 514 to both sides. 646.096. That's my test score. That is the 90th percentile. 90% of the data is to the left of 646.096. So here we have a similar question. Now we're talking about weights, which are also usually normally distributed. And we're asked to find two things. We're asked to find the 50th percentile and the 75th percentile. Well, sometimes we can take a little shortcut. Right, the 50th percentile is the median. Right, 50th percentile is the median. That is the value that has half of the data, or 50%, to the left of it. Okay, well remember, our normal distribution is symmetric. Right, it's symmetric with respect to the mean. In other words, there's 50% of the data over here and 50% over here. The dividing line is this value. So when we're talking about a normal distribution, the mean and the median are the same thing. So the 50th percentile, now remember our notation, right? I'm going to say P50 equals the median, which in the case of our normal distribution is equal to the mean, which I'm told here is 37 inches. So that wasn't too bad, right? Didn't have to do any calculations. All right, now for the 75th percentile, we're not going to get as lucky. For this one, we're going to have to actually use the method that we used on the previous slide. 75th percentile is going to be, I don't know, over here somewhere. Or someplace greater than 50. So I want 75% of the data to be in that section. So we need to find the z-score that has 75% of the data to the left. Well, I'm going to go to my table, right, and I'm looking here. I'm looking for 0.75, and I don't see it, but I've got this number here and this number here. Both of those are pretty close, right? So which one am I going to pick? Well, this one is about 0.001 off, about 1.5. This one is 0.0017 off. So it's a close one, but I'm going to go with this value here since it's just a tiny little bit closer. So what's the z-score for this? Well, I'm going to go over to the left, and I'm going to get 0.6. I'm going to go up, and I'm going to get 0.07. So this is 0.67. All right, great. Now I need to find the data value that corresponds to this. Now I'm going to go to my z-score formula. Bring it up a little higher. Z is x minus mu over sigma. So my z-score, that's 0.67 equals x minus the mean, that's 37 inches, divided by the standard deviation, that's 3.5 inches. So now all we have to do is solve this equation. Right? Let's multiply both sides by 3.5, right, and left. 3.5 times 0.67, that's 2.345 equals x minus 37. So I'll add 37 to both sides, and I get 39.345. And don't forget the units, inches. Right, so this is, right, we use our right notation here. This is P75, which of course you remember also happens to be the third quartile. So you see here we have something a little bit different. It starts off the same as the others. We're talking about mean or average weights. We expect weights to be normally distributed. And we're given information about the mean and the standard deviation. That's good. Now what we're asked for is the range of heights centered on the mean. All right, so I'm going to go, what that means is the mean is in the center of my range. I'm going to go down a certain amount, and I'm going to go up the same amount, and the area in here has to be 75%. Well, I can't just go and look up 0.75 in the table because the area to the left of this z-score includes not just this 75%, it also includes this bit, right? So I have to include that in my percentage. So here's how I'm going to do this, okay? If 75% of the data is here in the middle, that means 25% must be in these two outer tails put together. Well, because the graph is symmetric, the size of the left-hand tail and the size of the right-hand tail are the same. Each of them has to have half of the 25%. That means there's 12.5% over here and 12.5% over here. So that means this total area to the left of the z-score I'm interested in is 75 plus 12.5. It's 87.5%. That's the number I'm going to look up in the table. All right, so when I look that up in the table, what do I get? 0.875. This number is going to be the closest. That's what, 1/10,000th off. Okay, so what's my z-score then? My z-score is 1.1 plus 0.05. So this is 1.105. All right, that's going to give me my upper value. Right, my upper limit, let's call that x. Let's just call it x2. All right, so let me put a 2 down here. That'll be z2. X2 minus the mean divided by the standard deviation is going to have to be 1.105. So let's put our numbers in. X2 minus 156.5 over 26.5 is 1.105. And then we'll solve this. All right, I'm going to do I'm a little short on space, so I'm going to do the whole thing. I'm going to do 1.105 times 26.5 and then add 156.5 to it. That gives me x2 equals 185.8. And what are we talking about here? Pounds. So that's my upper range. Right, now how about the lower one? Well, look, I'm going to rely on this symmetry again. Right? If this point here is 1.105 standard deviations above the mean, then this point here, again, symmetry, it's the same distance, but in the opposite direction. So Z1 must be negative 1.105. And to get X1, I'm going to do the same thing. X1 minus the mean, that's 156.5, over standard deviation, that's 26.5, equals negative 1.105. And now again, I'm going to do all this once here. I'm going to solve this equation. 1.105 negative times 26.5 plus 156.5. It gives me my lower bound, 127.2 pounds. All right, so what's my answer then? 75% of the population are between 127.2 pounds and the upper limit, 185.8 pounds. Right? There are my ranges. Okay, so what's next? We're going to take a big step. We're going to take a big step in the next section. So far, we've been talking strictly about individuals. Right? What's the probability that an individual person has a weight above, below, between? In the next section, we're going to take a step and we're further, and we're going to start talking about groups. How can I find the probability that the average weight of a group of people is in a certain range or has a certain probability? Right? This is going to be a big step forward because remember, way back at the beginning of the class, we were talking about samples. Right? We're talking about samples taken from a population. So this idea of being able to talk about the probability of a sample being in a certain range is going to be a big step forward in our step towards inferential statistics, where we're going to be taking samples and trying to draw conclusions about the entire population.